Hello, I have Selena here with me to share another lesson about the layers of the earth or the composition of the earth. And we've talked a lot about how the heaviest particles, during that first great story, the heaviest particles were given the property of sinking to the bottom and the lighter particles to float to the top. And so we've talked about how the heaviest layers became, or the heaviest particles became the barosphere, and the lighter particles became the lithosphere, hydrosphere, and atmosphere, the layers that we see and use every day. And then we talked about how thick the layers were, and we learned that the barosphere is very thick, that almost all of the earth is made up of that heavy sphere, that the inside of the earth. And then we talked about the more details of the layers, and we talked about how there's the crust, the mantle, and the core. So within the barosphere, there's the layers of the core, and there's the layer that's the mantle, and that those are separated by weight within the core, or within the barosphere. And so then I want to talk to you more about the lithosphere, the stony or rocky layer, and that's why I have rocks here in front of us. So the lithosphere is really quite interesting. If you imagine back when the earth was first forming, there were no solid particles yet. It was all liquid. And so the heavy liquids were the center and the lighter liquids were on the outside. And so those lighter liquids on the outside were what eventually solidified and became rock. And that's what we have as our solid crust now. So I want to talk about two of those rock types right now, because these are the two types that make up the most of the crust or lithosphere. The first one I have here is a piece of basalt, and this isn't a great example. Basalt, I don't have a big piece of basalt, because if you've been in my class or heard my rock stories before, you know that I feel like basalt is an ugly black rock, mainly because basalt is what we see here in Eastern Washington everywhere. It's the columns that you see. It's a lot of our landscape rocks, and I usually jokingly call it ugly dark rock. So I don't actually collect any samples generally of it because it's everywhere. But for this lesson, I do have this piece. This is a special piece for another lesson as well. But I want you to look at it, and right along here, we can see that this is a very solid piece of rock. We don't see any crystals. What you're seeing is like a dirty, rusty coating on it. And then where we would see the crystals, it's really just solid and dirty. And there's some gas bubbles in there. We call those vesicles. So basalt is a very heavy, very dense rock where you can't see the individual crystals that make up the rock. Now, the other rock type that makes up the crust is granite. And there's also a lot of granite here. Mount Spokane is made of a big pluton, and a big piece of magma that crystallized into a rock. And it looks a lot like this. And on this one, you can see individual grains of minerals within this rock, especially this one. This one has really big white and pink crystals, and you see the black and white speckled minerals. So granite forms large interlocking crystals that you can see. Basalt does not form crystals that you can see. The crystals are so small, and they're interlocking too, but they're so small you can't see the individual grains. And so these are the two rocks that make up most of the Earth's crust. In fact, the crust, it's either, we talk about the ocean crust. Oceanic crust is basalt, and continental crust, where the continents are, is granite. And that's a generalization, meaning that's a general statement. But as far as the majority of the rocks that make up those surfaces, this is what the ocean floor is made of, and this is what the ground we live on is made of. Okay, so now that I've given you that example, I want you to see some rock examples. I'm going to set these aside, and I want to do a demonstration. So remember back when the crust was forming, when it was still liquid, we had basalt, which is heavy. It's iron, magnesium, it's very heavy elements. And then we had the granite. And when we've talked about the crust, the granite is made of calcium and potassium and quartz, silica. And so those elements that make up granite are just lighter in weight, also lighter in color. If you notice that, the granite's lighter in color as well as not as heavy. And so this water, there's water in here. The water in there is representing the basalt, And this piece of wood is going to represent the granite. Now, both of these make up the lithosphere. They both make up the crust. But when I set that in there, let me see if I can lift it. When I set that in there, oh, it's so hard to see. Let me see if I can tip the camera down. When we put it in there, you can see that the piece of fake granite is lighter than our water basalt. And so you can see, right, that's perfect right there. You can see that part of it is submerged in the water, but part of it is floating above. Now, when the crust was being formed, that's exactly what was happening. The basalt crust was sinking lower because it was heavier, and the granite crust was floating higher because it weighed less. And so I have a chart that helps us to look at this. So there we go. So here we have that plastic mantle we talked about last time with our crust mantle core lesson. And so here's our plastic mantle. And on top of the plastic mantle are the layers of the lithosphere. This is not to scale. Remember, the lithosphere is very small, but it's this big so you can see it. There is a thin layer of basalt under all of the crust. Just like when we looked, there's liquid water under all of this surface. And just like that, this chart shows that there's basalt under all of the crust. Now, some places there is no granite floating on it. There's no granite floating, and so some of that basalt goes all the way from the mantle all the way up to the surface. Now, over here and over here we have the solid granite. And if you look really closely, you can see that the edge of the granite is floating higher than the edge of the basalt because the granite doesn't weigh as much, and so it's floating just like this piece of wood is floating. It's floating just above the surface, not sitting on the surface. It's floating just above the surface. And so that difference where the solid heavy basalt is lower into the mantle and the lithosphere, the solid granite part of the lithosphere is a little higher, all of that low space filled in with water and became the oceans because the land is heavier, so it's lower and water flows down and out, and the lowest points on earth became the oceans. And so basalt is under all of the ocean. So that's why we call it oceanic crust, because it's under the ocean, and continental crust because it's under the continents. And so we've got solid granite pieces floating. They're not really floating, they're now solid, right? They were floating above the basalt, and now they have become hard rocky crust. Now, something that's interesting to think about is that they're not just slabs, solid slabs of pieces that have made one solid earth. We know that the pieces of the earth's crust are broken into pieces that are very large, and we call them plates. And those plates don't stay still. Those plates move. And we don't always feel it, but this spring, I don't know if you felt it, but there was some crustal movement happening, and there was an earthquake, and we felt it here. We were not filming a lesson, but it was very close to it. But the light over our table was swinging and we could feel it, especially for people who live in places along faults, which are the boundaries of plates, like in California and Alaska. You feel earthquakes all the time. So often that small ones are just normal happenstance. It doesn't even affect you. Whereas a small one happens here and everybody's like,
what's happening?
Did you feel that? Did you feel that? You call your mom, did you feel that? And so the movement of the plates, we can't always feel it. Sometimes it's so far down we don't feel it. We see the results though in the mountains and in the rocks that form in these areas. And so that's pretty cool. So today's lesson was to learn about the layers of the crust and how the crust is made up of heavy materials that make basalt or oceanic crust, and the lighter crust that's made of granite, which is lighter color and in weight. And so that's really interesting. So maybe you have a piece of wood that you can float. This was Abby and part of a project Abby had done or something. And anyway, we just have that extra piece of wood and a little basin of water, and we can imagine how the plates, the continental crust, are connected to the oceanic crust, but broken into pieces that still move in relation to each other and change the surface of the earth as we see it. I hope that you learned something new from this lesson. This is further details of the crust, and I have many more stories to tell you about the earth and its parts. I hope to see you next time. Make sure you share your follow-up and share your learning with your family. Bye-bye.